So in this video, we are going to start a new chapter. It's called chapter number 8. Okay, it's chapter number 8, quadrilaterals. So it's a brand new chapter. This is the first introductory video where we're going to start with the basic definition of what exactly is quadrilateral and what is this new geometric figure. We have seen circles, we have seen triangles, we have seen lines, we have seen parallel lines, but now a new geometrical figure, a new geometrical shape that we are going to get acquainted with is called quadrilateral. So let's quickly see what is the definition of quadrilateral. So let's read it. A quadrilateral, so Q dot is a short form for quadrilateral that I am using. A quadrilateral is a figure formed by joining 4 points in an order. This is a very important point. In an order, we have to join 4 points in an order. So let's take an example. Let's say this is my point number 1, point number 2, point number 3, point number 4. And I have asked you to join these 4 points. Now there are multiple ways to join these 4 points. For example, first way is, I'm going to use a highlighter. First way is like this: 1, 2, 3, 4. I have joined all the 4 points successfully. However, am I following order in the joining? No. I'm randomly jumping to any random points and going wherever I want. So this is definitely not a quadrilateral because we did not join the points in an order. So once again, let's erase these highlighters. Okay. Okay. So I hope you got the concept. The concept is to join the points in an order. So start from any point. Let's say I will start from this point. Okay. Then go here, then go here, then go here, and then go here. So we have thus followed the order like this, then like this, then like this, then like this. We did not jump across different points. So if you join 4 points, okay, 4 points is another important thing. Any 4 points which will be joined in an order, okay, in an order, you will get a quadrilateral. So that is the concept of, or that is a very simple definition of a quadrilateral. Let us erase this and draw a better quadrilateral. So let's say this will be my quadrilateral here. Okay, I think I'll take the shape. Yeah, yes. So this is my quadrilateral. Why is it not connect? Okay, and I'm going to name it. So let's come down. Okay, so it has 4 vertices, as you can see: A, B, C, D. Now, what does a quadrilateral consist of? There are 4 key characteristics of a quadrilateral. So let's start mentioning them. I'm going to write here 4 key characteristics, okay, of a quadrilateral. Okay, so they are quite straightforward. First is it will have 4 vertices, quite obvious because there are 4 points that we're joining. So quadrilateral will always have 4 vertices. Second thing, it will have 4 sides. Okay, a quadrilateral will have 4 sides: AB, BC, CD, and AD. And last, again very obvious, it will have 4 angles. So every quadrilateral will have 4 vertices, 4 sides, and 4 angles. This is quite similar to triangle, where every triangle has 3 sides, 3 vertices, and 3 angles. However, quadrilateral has one more important thing. I want to use a different color. One more important thing, and that's called a diagonal. So every quadrilateral will have 2 diagonals. Okay. Now we will see what is a diagonal. So here is the definition of diagonal. Let's try to get rid of this. Yes. What is a diagonal? A diagonal is a line which joins opposite vertices of a quadrilateral. Let's highlight the keyword here: opposite vertices. A line which joins the opposite vertices of a quadrilateral. So once again, let's consider this quadrilateral. Okay, A, B, C, D. What are the opposite vertices? I'm going to highlight them. Okay, so A and C are the opposite vertices, and B and, okay, let's do a different color, and B and D are opposite vertices. So we need a line which joins opposite vertices. So I'm just going to join this BD. This is one diagonal, and AC is my another diagonal. Okay, so again, very simple, straightforward definition. What exactly is a diagonal? A line which joins opposite vertices of a quadrilateral. So that is our fourth. This is the fourth key characteristics that a quadrilateral will have. Of course, it will have four vertices, four sides, and four angles. Along with that, every quadrilateral will have exactly two diagonals. So that's an important point. Now, let's move to an important property of a quadrilateral. It's called angle sum property of a quadrilateral. What does this mean? Here is a definition that I mentioned for you. Okay, let's read it out. So, sum of all four angles of a quadrilateral is equal to 360 degree. So, let us draw a quadrilateral quickly for our understanding. Visuals are very important. We have to visualize and only then we can. Yes. So, this is a quadrilateral. Let's give it a name. Let's name the vertices. So, A, B, C, and D. Now, what the property says is, let me try to get it a bit away. Okay. So what does this angle sum property say? That sum of all four angles, we know there are four angles of a quadrilateral, A, B, C, D, that is equal to 360 degree. Now the proof of this is quite simple and straightforward. I'm going to write a proof. Okay. So we'll construct, so step number one, construct a diagonal, just one diagonal, construct one diagonal, okay, in the quadrilateral. So let us consider BD. I'll construct BD as one diagonal. Okay. Now, as you can see, this quadrilateral now consists of two triangles. So we have triangle ABD and triangle BCD. These are the two triangles inside a quadrilateral. Now we know that sum of a triangle, sum of all angles of a triangle is equal to 360 degree. So this angle, so I'm going to use a highlighter now. So this angle plus this angle plus this angle is equal to 360 degree, and this angle and this angle and this angle, sorry, is equal to 180 degree. So, okay, let me repeat. So the green ones, okay, so the A, B, and these three green dots, summation is going to be 180 degree because it's a triangle. And then the pink dots, again, this, and this, their summation is also going to be 180 degree. Why? Because those are two triangles. And finally, if we add all these angles, it is going to give us 360 degree, 180 plus 180. That's a very simple proof of this angle sum property. I'm just going to write down the steps. So, in triangle AB, okay, so in fact I can do like this. Okay, for triangle ABD, I'm going to say angle A plus angle ABD plus angle ADB is equal to 180 degree. Okay, and for triangle BCD, okay, let's just bring it like this down. Okay, for triangle BCD, I want to have angle C. So angle C is like separate and independent. So I'm just writing angle C plus angle DBC, okay, plus angle the CDB, angle CDB is equal to 180 degree. Okay. Now what we're going to do is we're going to add both of this. Okay. So that will be my step number 4. Let's move. Step number 4. Add both above equations. Okay. So note this is angle A and angle C. So that will come as it is. So I'm just going to write angle A plus angle C. Okay. Plus. Now this is interesting. ABD. So hold on. Let's use a highlighter so that it's easy to understand. Let's get rid of this first. Yes. Now angle ABD. So this is my angle ABD plus DBC. So this is my, okay, this is that angle, and then DBC. This is that angle. So this angle plus this angle is actually equal to angle B. So both of them are going to give you angle B. And I'm going to use the same highlighter so that we understand it. Okay. And now similarly, let's erase this first. Similarly, when we add ADB So this is my angle ADB. So this is the D plus CDB. So CDB. So this is that angle. When we add these two angles, we get this whole angle D. So that's what's going to come here. That is going to be plus angle D is equal to what is 180 degree plus 180 degree? That's 360 degree. This is equal to 360 degree. Okay. And thus, let me box this important equation that we have got, that angle A plus B plus C plus D, that whole summation is equal to 360 degree. And thus we have proved this angle sum property of a quadrilateral, that sum of all four angles is equal to 360 degree. The simple and very straightforward understanding is every quadrilateral, let's erase this. Okay, every quadrilateral consists of two triangles. Okay, and sum of one triangle is equal to 180 degree. So if there are two triangles inside a quadrilateral, the summation of angles is going to be 360 degree. So that's also a simple explanation for this angle sum property.